Hey everybody, welcome to class. It's Dr. D, and today I'm going to be showing you two strategies to help you find the least common multiple, or the LCM. Now, in math, sometimes we need to find the least common multiple. Most likely, you need to find it if you're adding or subtracting fractions, and you need to change your fractions to like denominators. This is a common time you'll have to rewrite the fractions into equivalent fractions, and you do this by finding the least common multiple. So let's go ahead and we'll start with our first strategy, number one, which is the list method. And what we're looking for is the smallest multiple or product that two numbers have in common. So it's the same. So let's say I was looking for the least common multiple of 4 and 12. I'm going to just start by listing all the multiples or all the products of 4 and 12. And what I do is essentially just stop when I've come across one that's the smallest same product. So we begin by just listing the multiples, starting with 4 times 1, which is 4. 4 times 2, which is 8. 4 times 3, which is 12. Times 4, 16. And actually, I can stop here because 4 times 3 is 12. And I know that 12 times 1 is 12. And as you can see here, that is the smallest common multiple, the smallest product for both 4 and 12. So the LCM is 12. All right, let's try another example. Again, we're looking for the least common multiple. And this time, let's pick two new numbers. And I'm going to pick another color. Let's pick 6 and 8. So, once again, we're going to get started by listing all the multiples of 6. 6 times 1, 6. Times 2, 12. Times 3, 18. Times 4, 24. Okay? And I have what I'm multiplying 6 by at the top. I'm going to stop here because I know that a number times 8 is also going to give me a product of 24. You may know that multiplication factor already. So if we went ahead and list 8 times 1, 8 times 2, 8 times 3. You got it. It's 24. So our LCM is 24. Now, the list method is really good when we have friendly numbers, but sometimes we come across a number that it's not so easy to multiply, like 12 and 16. These are not numbers that we commonly multiply. Maybe the multiplication facts by 12, but another way that we can do this when we have bigger numbers is called Prime Factorization. Okay, and what we're doing is we're breaking apart numbers into its prime factors. So factors are the numbers that we multiply together to make the bigger number here. Kind of like a number bond, okay? So we can think about what number times another number will give me 12. And we don't want to do 1, so we want to break apart 12. So let's just say I did 3 and 4, because I know 3 times 4 is 12. I'm going to start looking for those prime numbers. 3 is a prime number, which means it's only divisible by 1 itself. The only way to make 3 through multiplication is 1 times 3. But I can break apart 4 into 2 times 2. Now I have broken apart 12 into its prime factors. 12 is 3 times 2 times 2. Do the same thing with 16. I know 16 is 4 times 4, and I have a 2 times a 2 times a 2. And the next step in this strategy is you list all the prime factors. So once again, 2 here is a prime factor because it's only divisible by 1 itself. I can't break it down anymore. But this strategy, what we do is we line up the prime factors. So you can see here that I already have a 2. I'm going to line it up with this other 2. And I already have another 2 here. Those line up. And the reason that we do this is we are going to multiply all the prime numbers, but not the ones that are matched. We only multiply this once, okay? So essentially what we're gonna do is multiply these prime numbers. So we start with 3. 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. So the prime factorization of 12 and 16 is 48. Now, of course, I could have listed all of the multiples of 12 and 16. I could have used that list method, right? And if I do that, 12 times 1 is 12, 24, 36, 48. No biggie. 16 times 1 is 16. 16 times 2 is 32. And then 48. So, same answer, just a different method. Again, it's a helpful strategy when we aren't super familiar with all the multiples of a number. Let's try another one. 25 and 18. Again, we're going to use prime factorization. This should be pretty straightforward because the factors of 25 are 5 and 5. And then the factors of 18 are 2 and 9. Okay, 2 is a prime number, 5 is a prime number, 5 is also a prime number, but this number 9 here, I can break it apart because I know 3 times 3 is 9. Now I have all of these prime factors. What I'm going to do is just multiply them all together. 5 times 5, 25. That's the same. Those prime numbers make the number. And 3 times 3 is 9 times 2 is 18, also making 18. So essentially, in this situation, all I'm doing is multiplying 25 times 18. I'm going to go ahead and use the strategy where I break apart 18 into more friendly numbers because I know 25 times 10 is 250. And if I was to take out 2 groups here to make 8, because 10 minus 2 groups is 8 groups of 25, that'll get me to 200. And I just add up these partial products. The answer is 450. So there we have it, 2 strategies to find the least common multiple.